Hello everyone, I am Farah Aidar. I am PhD student at Renault and Institut Polytechnique in Paris. I work also in the Secure Cooperative Autonomous project of the IRT System X. I will present today my paper, there, a reports data set for global misbehavior authority evaluation in the context of CITS. The CITS aims at improving road safety and traffic efficiency. It is composed of 3 layers. The first one is the vehicles that can communicate using ITS G5 technology or also the cellular technology such as 4G and 5G. Vehicles exchange 2 types of messages. The first one is the CAM messages, cooperative awareness messages, that's called also beacon messages. These messages contains information about the position, the direction, and the velocity of the vehicles. It is used to announce the vehicle's presence on the road. The second type is the DENM messages, which is used by the vehicle to announce an event on the road, such as an accident, for example. The second layer is the roadside units, antennas, and also the cellular antennas. The back-end layer is composed of the public key infrastructure and also the misbehavior authority. The public key infrastructure is a set of entities that is used to deliver digital certificates to the vehicles. These certificates are used by the vehicle to authenticate themselves during the communication, um, and the misbehavior authority that aims at investigation on misbehaving entity on the network. The public key infrastructure can protect the system from external attackers, which are vehicles without valid key materials or valid certificates. On the other hand, vehicles with valid key materials can still perform attacks on the system. For example, I will give here example of 2 attacks, the Sybil attack and the false alert attack. For the Sybil attack, the vehicle uses multiple valid pseudonym identities or certificates to create ghost vehicles on the road, and thus disturb the system credibility. And the false alert attack is when the vehicle, a valid vehicle, send a fake notification that there is an accident on the road. The solution is to have a mechanism that can detect these misbehaving entities. That's what we call the misbehavior detection. Many detection levels exist in the literature, such as local detection inside the vehicle, or also cooperative detection. That means when the vehicle detects a malicious event, it sends it to the neighbor vehicle to ask them if the information is correct or not. And finally, the global detection, where a global entity investigates on the report sent by the vehicle to detect if the malicious vehicles on the road. We precise that in this paper we work on the context of the global detection. The misbehavior detection process is composed of 3 steps. The first one is the local detection, where each vehicle performs some local plausibility and consistency checks to detect if there is a malicious or misbehaving entity. If an anomaly is found, the vehicle creates misbehavior report and send it to the global authority called misbehavior authority. The third one is that the global misbehavior authority is responsible for collecting and analyzing reports and there's where our contribution lies. So as I said, in case of detection of malicious activity, the vehicle creates a misbehavior report and sends it to the misbehavior authority. The report format that we propose is presented here in this slide, and it is composed of three parts. The first part is the metadata, such as sender ID, reported ID, the generation time of the report, the reported real ID, etc., and that attack type also. The second part is the messages used in the local detection, which means the evidence of the malicious events. And the third part is the checks used in the local detections, such as range plausibility, position plausibility, etc. In this paper, we propose a misbehavior reports dataset because the misbehavior detection is required in CITS. There is many standardization bodies and groups are working on this subject, but until now there is no clear vision on a good solution. And many investigations and propositions need to be done in this context. And also the main motivation is that there is no existing data set, simulation, or real data in the literature of reports, misbehavior reports. And our proposed dataset can help researchers to test their misbehavior detection solutions and thus find the best solution. We used two scenarios to generate our report dataset. The first one is the Luxembourg scenario, and the second one is the Paris-Saclay scenario. So as we can see, this is the first one, and this is the second one. And we can see that there is different areas and different densities between each scenario. And also there's different route configuration. Also, we implemented different type of malfunctions and attacks. In this dataset, we start with the malfunctions. We implemented the position malfunction and the speed malfunction, and also delayed messages where the broadcasted information is correct, but it is sent with a delay of few seconds, for example. The attacks that we implemented are the sudden stop, where the attacker simulates fake sudden stop of vehicles, denial of service, the Sybil attack. We implemented multiple type of Sybil attack that we called DOS disruptive, DOS random Sybil, and data replace Sybil. And also we implemented combination of attacks, the combination that may include different type of previous listed attack. I present here an example of a scenario. For each scenario, we specify the ID that we gave. And the network type here, for example, it is lost, which means it is a Luxembourg scenario. The time, and for the attacker, we specify the rate of the attacker, which means 25% of the vehicles are attacking. Here the type is malfunctions, and the number, we precise also the number of vehicles and the number of messages exchanged. And also for the genuine vehicles, we precise the number of vehicles and the number of messages, and the number of reports sent after detecting that there is a malicious entity, and also we precise the file size in plain and zipped for each scenario. Our data set is available on this link, so you can download it for free. And also here we present all the scenarios. We can see that we have multiple network configuration that time, and multiple different attack rates, different type of attackers, and we precise for each scenario, as I said, the number of vehicle and the messages, also for the Gen 1, the reports, and also the file size, as I presented before. For the conclusion of this work, we see that the global misbehavior detection in CITS is still an ongoing research topic. Standardization in Europe and US are working on this subject. Our contribution consists of providing a large data set of misbehavior reports for comparative evaluation of global detection solutions, and our future work is to deploy and test of a variant of global solutions on CITS field test in France. Thank you.